folks who are in here hear me just fine?
Yeah.
Can people who are in nod if they can hear me okay? Great. Okay, we're in business. Okay. Wait 1 minute for people to keep streaming in. I'll get started about 3:30, 3:31. Hide these meeting controls. Okay. Okay, I've got 3:31, so you've got about 30 people in chat. That seems like a pretty good ballpark for a start. Imagine people keep streaming in. So first of all, we've got chat back again. So I had it disabled on, I forget if it was lecture or lab. Chat again, we can once again use normally for asking questions. If you raise hand in here, I have participant view up. I should be able to see you, that kind of thing. So, go ahead and ask questions. So I'm just going to go ahead and get started here. So yeah. Okay. So today's lecture is on visualizing data with ggplot. But before we do that, I want to go over a few useful things and also do a brief introduction of dplyr, which we'll need to prepare data for visualization. Okay. So first of all, you've probably noticed, or if you were in lab, you got to hear me talk about, sometimes I will write code in the slides that looks sort of like this. We'll have maybe some R code, like create a new object like this, and then there will be a pound sign over here, and then I'll say something like this, like making a vector out of 1 to 10. So that pound sign or hashtag is the commenting symbol in R. Anything you write on the same line after that symbol will not be run as code in R. So this is something that's useful for annotating your code so you can remind yourself or people you work with what you're doing in a section. The more complex your code is, the longer and more detailed your comments should be. Typically, when I write some analytical script or something, I will have a really big comment at the top that has all sorts of information, like the last time I worked on it, what the goal of this particular script is, how it fits into my project that I'm doing. In our Markdown documents, you probably write less comments because you can instead document your analysis with inline text all over the place. So instead of having a comment saying, this is a vector of 1 to 10, you could literally just have text above it saying, I'm going to use this code here to make a vector of 1 to 10. So Markdown documents, you often put your documentation as raw text. In scripts, you basically have to comment if you want documentation. Okay. Okay, can you go over how to open an R&D file from GH so we can go follow along? So is this GitHub? Okay, so there's a couple different things we can do. So somebody asked me basically, how do I follow along in the slides that we're doing? I'll show everyone. It's pretty straightforward. If I drop here, I say, go to the website. If you wanted to follow along and run the code, you have two options for following along. The way I would generally recommend doing it, which is a little bit more straightforward, is to use the .r file here. And for the .r file, it looks kind of like this, right? It's a pile of R code. You would have to right-click, save link as, download this somewhere. So for instance, I can put it here in downloads. Click on it, RStudio should open it up. This has all of the code used in the slides in it as an R script file instead of a markdown document. The alternative thing you could do is you could download the RMD. So I could say, go save link as, ooh, excuse me, downloads, pop open the RMD file, and then the RMD file is the actual code that generates the slides used in class. It has a bunch of extraneous stuff that might be confusing or unfamiliar. For instance, the header up at the top is enormous and has a lot of stuff because I use fancy slides and they have way too much code in them. In this one, it has all the text in the slides too, not just the code, so you could follow along seeing exactly what's in the slides. You can do either one you want. So the slide code, if you use the RMD, every once in a while something might not run because some of the chunks aren't meant to be run. Like you might find something that says eval equals false. This is something you're not meant to run on your computer, but is an example like on screen. So the slides can be a little bit more confusing. I recommend the .r file. Okay, so back to the lecture. So, and also when asking questions, if possible, instead of doing a private message, do it globally so everyone can see it. As it turns out, the private messages will still be displayed in the transcript, so your secrets are not safe with Zoom. Okay. So, anyway, yeah, so comments, they work inside our Markdown chunks, but if you do a comment symbol in an R Markdown document, it's going to become a header. So comments are really just for scripts and chunks. Okay. So next. You can save files that you've created in R. When I say files, literally any object in R can be saved onto your computer. You do this with the function save. You would say save the name of the object in your environment and then file equals whatever you want this file to be named on your computer. This will save a file onto your computer. You can also open saved files using the load function, in which case you just give it the name of that file that's on your computer. So this first line here would save some object I created called new object as new object.rdata on my drive, and then this would load it back into R. It would appear in my environment as new.object, whatever object name it had when I saved it. Okay, here's a question. Can you remind us when the peer reviews are due? Also, are we assigning a grade to them or just writing some comments on the assignment in Canvas? So the peer reviews are due a week from when the homework is due. So when you're turning in your homework for this week, so you're going to turn it in on by midnight this coming Tuesday, your peer review for the previous homework will be due at the same time. So things are just kind of staggered 1 week. As far as the assigning the grade to them, yeah, you can do like somewhere between a 0 out of 3 and a 3 out of 3 as your recommendation. Those are not sticky grades. I basically will never reduce somebody's grade. If somebody gets a 3 on then I'm probably not going to reduce it, but I often bump people up because sometimes peer reviewers are a little harsher than I would be, especially early in the class. But yeah, the recommended grade is useful because if somebody puts in like a 1 out of 3, I'm going to go through the thing with a fine-tooth comb and find out exactly why they said 1 out of 3. 3 of 3s, if I'm probably going to glance at it a little faster. If it looks good to me on the first pass, I know it's fine. So basically, the lower the grade is, the more time I spend on the homework trying to correct problems. So it's kind of a guidance to me. They aren't sticky grades. You're not like grading people and having them stick. Everybody usually does better than the average peer review. Okay, great question. Anyway, back to loading and saving files. So a question you may have, which is a reasonable question, is if I am saving and loading objects in R, where are these files being saved and loaded from? So the answer to that is what is called a working directory in R. Working directory is also something that exists in like Stata and other software like that. It's sort of where the software is currently looking for things. If you want to know where your current working directory is in R, the function getWD shown here will show where your R is currently looking for files. So when I knit these slides yesterday, I think was the last time I renovated these, my working directory was my C drive, users, CCLAN, OneDrive, GitHub, this class's directory, the lectures directory, and my week 2 lecture directory, right? So you can see the whole file structure I have set up for my class here. It looks just like that, right? So that is your working directory. If you save something, the file will end up in that directory. If you try and open a file, it's going to look in that particular directory. You can set a new working directory. So if you want to change what your current working directory is, the function is setWD, and you can provide a new file path. So if I wanted to change my working directory to my documents folder, I could say set wd c:/user cclan documents. And now anytime I save or load a file, it would save it or load it from that documents directory. Okay. The thing is though, if you're working in an R Markdown document, do not set a working directory. The way our Markdown documents work is they automatically set the working directory for every chunk in the document to whatever folder that file is in. If you set a working directory in one particular chunk of your Markdown document, once it goes to the next chunk, it's going to reset that working directory to another location. Generally, you just want to make all your files in the same folder as that Markdown document or a subfolder under it. And that way they're all kind of mobile and you're not setting specific directories. So here I have a couple questions here. When you do set working directory, is it a permanent change or just within the script file? That set working directory will go for as long as you're in your current R like instance. If you change projects, the working directory will change. If you change it again, if you close R and open it back up again, the working directory will change. But it just stays that way until you either close and open R, you restart your R instance, or you open a new R project. Another question, can you have spaces in the file name? You absolutely can have spaces in a file name. If your operating system supports spaces in file names, then you can have spaces in file name. All modern operating systems do. I just tend to err on the side of not putting spaces in things on those rare occasions when software gets angry about spaces. Most of the time, R is pretty tolerant of it, but to be safe, I usually like to use underscores. It's perfectly fine to use spaces though. In fact, I'm going to give some examples of you using spaces in R object names either this week or next week. So you can go wild with your spaces. Okay. So this leads to managing files in R. When you're managing R projects, in my opinion, my authoritative opinion, it's normally best to give each project, that being something like a homework assignment, or in my case, like a class, its own folder. I usually use the same general system. I will have every class or project will have its own folder. Each assignment or task of that project will have a folder inside that, which will be the working directory for the items in that folder, like our Markdown documents or the slides for this particular lecture. The .rmd and .r files, if you use whichever you're using, will be named clearly and completely. This results in something like this. The file for the lecture you're currently looking at is named this and is in this location. It's in my GitHub because it's hosted on my GitHub webpage. The class is CSSS508. This is a lecture, so it's in a lectures folder. It's a week 2 lecture, so it's under week 2. And then underneath week 2, it has a complete file name of CSSS508 week 2, the topic and .rmd. The nice thing about this is if this file ends up anywhere on my computer for some dumb reason, I know exactly where it goes. And then for every other file I'm working with, I know exactly what folder they should be like in my overall structure. More folders are better. One of the nice things about computers is you can infinitely basically nest them in folders. You should take advantage of that. And it's nice to have fewer files inside a folder, and ideally a folder should contain all files of the same type. I will rant about this for far too long in the week 10 lecture, but this is just a preview of that. Okay, so you can use whatever system you want. My particular system is what I use, but it's not like some thing that's a standard. The main thing is you should be consistent so your projects are organized. You don't want to lose your work by, say, misplacing a file. If you have a big documents folder and you have a million different files named new file 1, you're going to overwrite things sometimes. And you don't want to just like have a million files where you can't find the one you're after. Nesting things inside folders helps. It keeps you organized and everything. Beyond that, I highly recommend that you have every single project actually has the same folder names inside of it, so you never wonder where to find a particular item of a type within a project. I actually have functions on my computer. I press one button and it builds all the folders for a particular project. It's really kind of nice. Like I have a syntax folder for script files, a docs folder for documents, data folder for data, and then inside that, derived data and raw data. Raw data is read-only, that sort of thing. I'll talk about it in week 10, but building some sort of a system helps you be consistent, and over time, you're going to end up with a lot of stuff, so it's a good idea. Okay. Oh, here's a great question I just got. What if we would rather our files be a mess and just search for them? That is perfectly fine until you need files that reference one another. It can get really hairy if they reference one another. If you structure things nice and hierarchically in a project, it will make your projects very easily mobile, transferable to other people, that sort of thing. We'll kind of get into it later. Searching is okay kind of for humans consuming it, but once things are talking to each other on the computer, it's much easier with hierarchies of different types. But we'll get into it later. Whatever works for you though, if it works for you and it's efficient, you stick with that. And that's really kind of the way everything in grad school or whatever works. You figure out a system, don't try and copy other people's systems unless they're very similar to you in their work style. Okay. For large projects containing many files, for instance, this course, I recommend using RStudio's built-in project management system. If you go into RStudio, in RStudio window, up here in the top right is a project management system. You can create and open projects up here. The cool thing about this is that the projects will maintain open tabs that you have and stuff, and they'll set the working directory automatically to whatever that project's root folder is. So this is the project for this particular class. If I want to swap to something like I recently did a bias and policing report for the police department, I can click on this button over here. It's going to open up all the tabs I had up before, which is the report I was working on. It sets the working directory to that report, and I can pick up right where I left. If I want to go back to my CSSS class, I go like that, and I'm right back where I left off. The exact same tabs are up. I'm in the exact same state. So rather than having to completely clear out your RStudio session every time you move between projects, I just have a menu up here where all my recent projects are here. I just browse between them because I'm constantly jumping from one project to another. It's a pretty good feature. Okay. Oop. Okay. Okay. So if you're working on a journal article or a UW dissertation or thesis, I recommend using something like Ben Marwick's RR tools. You don't have to use all the features. It's pretty complex. RR tools or the Husky Down package for sort of managing these projects. What the Husky Down package does is it allows you to use an R Markdown document, but when you render it, it pops out in the University of Washington's official thesis or dissertation format for submission to the grad school. So you don't have to do any of that manual formatting anymore. It just does it out of an R Markdown document. Really cool. For journal articles, same kind of thing. If they have a specific format, you can just make your R Markdown document, render it in that journal's format, and take care of all that annoyance. Okay. So, file types. We're mainly working with 3 types of files in this class. We work with RMD files. These are markdown syntax files. This is where you write code when you want that code to eventually make a document of some kind, that being an HTML document, a Word document, a PDF, or slides like these, okay? There are .r files, I sometimes call script files or syntax files. This is where you write code that processes and analyzes data, but it doesn't make an output document. It might produce files or something like that, but it's primarily made for working on the data, producing like raw R output. It doesn't make a document. And then there's also .html or .pdf files. These are the output documents you would create when you knit a markdown document, but wouldn't typically be produced by a .r file. Okay. Yeah. If you have any questions on these or you need clarification on file types, what they're for, how to use them, things like that, definitely shoot me questions early. It's not good to be like confused about this particular thing, but it's okay to be confused about it. This class is a constant deluge of information. I understand it. Stop me when you need me to stop. Okay, so that's sort of some intro or background material. Now we're going to get into some actual R code that's useful. For this lecture today, I'm primarily going to be using the Gapminder data set. So the Gapminder data set is sort of like demographic and development indicators from different countries in the world. We're going to be using a nice clean excerpt of these data in the Gapminder package, which has been cleaned and assembled by Jenny Bryan, one of the big people in the R community up at UBC. To get this package installed, you can just do in your console, install.packages Gapminder, and then library Gapminder to load it, okay? So if you do that, you can then do structure on these Gapminder data. So much like the Swiss data that we used for the homework assignment, once you've loaded the Gapminder data using library Gapminder, you can access it just as an R object. So you can say things like str Gapminder, and you'll be able to see this. So here's a good question. If you don't know if you have a package installed, what's the best way to check? The easiest way to check is to just try to load it. Do library Gapminder. If you don't have it, it will yell at you. If you do have it, it will just work and it won't give an error message. Okay, great question. So these data loaded up here, we see that they are, the data type here is a tibble. We'll talk about these a little bit more, but a tibble is just a type of data frame for tidyverse style operations. It has 1,704 rows or observations, 6 columns. Those columns are a country, a continent, the year, life expectancy, population, and GDP per capita. Okay. So what's interesting about these data? These data have 2 factor variables. We see back here factors. Factors are a type of categorical data that have an underlying numeric representation. We're going to spend altogether too much time on factors later, starting in week 4, but we'll get there. There's many observations in here. My math didn't render properly. That's annoying. So n equals 1,704 rows. That's a pretty large number of observations. You probably aren't going to be manually perusing these data and doing operations on them like in Excel or something. There's a nested or hierarchical structure. There are year observations of countries, and countries are nested in continents. These are panel data. If you're familiar with panel data analysis methods, this is sort of what you would apply those methods to, right? Multiple observations of the same units over time at even intervals. Okay, so to work with these data in ggplot and do our visualization, we need to be able to subset our data and select specific columns, specific rows to do our plotting. We need to be able to do some light manipulation of data. So to do that, we're going to want to use packages in the Tidyverse. So I asked in an email that everyone install packages Tidyverse. Hopefully you've done that, because if you're doing it right now, it can take a long time to install. So almost all the packages that we use in this class are in this Tidyverse family of packages. They are pretty much the dominant way of doing data manipulation and visualization in R at the moment. They're not the only approach. And once you get into much larger data sets, you'll want to talk about other methods that are faster, for instance, data.table and things like that. But it is sort of the most common way most people work with R. It's straightforward, user-friendly, and pretty well supported. So what we want to do is we want to just do some basic subsetting of our data for ggplot. We're going to use a package called dplyr to do this. It's just one of many packages in the Tidyverse. ggplot2, of course, is also in Tidyverse. So if you've installed it, you have ggplot, you have dplyr, and you also have most of the other stuff we're going to use in the class. Okay, so if you haven't already, go ahead and do install.packages Tidyverse, and then go make yourself lunch or something, because it's going to take a while to install. Okay, it's going to install a ton of packages. The main one we want right now is dplyr. This is a really useful package, very powerful. We're going to talk about all next week, but we're just going to use it right now for filtering data. Okay, so you would load dplyr with library dplyr like any other package. Okay, oh, it actually didn't show my error. That's kind of funny. So, oh, wow, that's interesting. If you do library dplyr, everyone do that. Do you see something that looks like an error message pop up when you do it? Something pops up in your console. I'll see if we can do it here as an example. If I do library dplyr, I see something like this. Do you see red text like this when you load? Okay. If you're nodding no, you may have already had the package loaded, or you did library tidyverse before, in which case it will already have been loaded, so it won't kick this message. So when you did library tidyverse, it probably also kicked out something interesting. Okay, so this is not actually an error message. This is what happens when you load a package in R that has functions in it that have the same names as functions you already have loaded in R. What happens is it masks them. That is, the most recently loaded ones, that is the ones in dplyr, named things like filter, will overwrite the ones that were already loaded, okay? This is what's called a message, and it's just letting you know it did that. The reason for that is if you loaded dplyr and you were expecting the filter function that was built into base R to run, it wants to let you know you're instead going to get the dplyr version of the filter function. This is something relatively common. Some packages will have some commonly used name. Like, for instance, a commonly used package called mass, capital M-A-S-S, has a function in it called select. dplyr also has a function called select in it. It can be very confusing if you load both of these packages and you don't know which select function you're using. I'll talk about how you can use like masses select and dplyr select in the same script, either in this lecture or the next lecture, but it's possible. So again here, somebody said, nothing pops up when I type library dplyr in my console. Most likely I already had it loaded by having library tidyverse loaded, in which case that message popped up when tidyverse was loaded. The next, can we use the functions for the packages that are overridden? The answer is yes. Might as well just show you. So if you say I'm going to do not load this package, but if I load library mass here, library mass will mask off dplyr select function, meaning if I try and run select in dplyr, it's not going to work. Instead, it's going to load masses one. If I wanted to run the dplyr one, I could now tell R this. I could say, take the dplyr package, : select. This is R's way of saying, look inside this package for this function. So you don't need to load the mass function if you want things out of it. You could say, for instance, a common thing people load the mass package for is negative binomial generalized linear models, third term stats for most grad students. You could say mass glm.nb and run that function, and you wouldn't have to load that package at all. This is something commonly done if you don't want to load an entire package and you just want to run like one function out of it. Okay. So here's another really good question. For packages that we have already installed and use often, is there a way to have them automatically load every time we open RStudio, or do we need to reload them every time? The answer is you can do it automatically, but I will in the strongest terms recommend not doing that. The reason for it is because ideally every RMD document, every script document should be relatively standalone. You should be able to hand that script to people and have them know what is necessary to run that function. And by hand somebody, I mean future you as well. You don't want to be in some situation where you reinstalled R and you don't know what packages are necessary to run your files. So I highly recommend you just begin your scripts, your RMD files by loading the packages you need. Something that makes that really easy is that almost all of the commonly used packages most of you will probably use for data manipulation and visualization are already in the Tidyverse package. So if you do library Tidyverse, it will load the most commonly used 10 packages or so for most people. So it's one library call. But a normal script of mine typically will have all the packages loaded at the start. For instance, if I load up this bias report I just showed you a minute ago, you will see at the very beginning of my Markdown document, these are all the packages used inside this particular Markdown document. I just put them all there. They're up front. I'm not expecting anything to already exist or be loaded, which means if I hand this RMD to somebody else, as I did, because I handed it to their data person at SPD, they can replicate this work by taking the raw data I give them, installing all these packages and pressing knit, and they'll get the exact same result. So I like to have things self-contained. It's a good principle of sort of reproducible research. Okay, great question though. So, if you want to hide this loading message from like dplyr or Tidyverse, I normally put all of my packages in a chunk at the top of an R Markdown document and set include equals false up there. That will just suppress all loading messages, everything, it'll just hide it. Okay. Sometimes when you load a package, you'll actually get a real warning message. It'll look something like this normally. It'll be like, warning message, package Gapminder was built under R version 3.5.3. This is R's way of saying that the package was created under a newer version of R than the one you have. This is R's way thus of saying you have an out-of-date R installation. You can hide this message using message or warning equals false or include equals false, or better yet, update your R installation to get rid of it permanently. Okay. So, something dplyr brings that's super useful is called the pipe, or the magrittr forward pipe operator. The pipe operator allows us to pipe data between functions. So let's say we needed to get the log of the mean of Gapminder's population variable. We normally would have to write something like, take the Gapminder data, subset and get the population variable, take the mean of that, and then take the log of that. Okay, So I am not familiar with any human languages that read inside out, so I find inside out functions like this to be somewhat inconvenient to read. So for the rest of this class, we will abolish this convention. Pipes allow us to write our code from left to right, or right to left if you use the pipe going the other direction, depending on which way you prefer to read things. Here, this says, take the Gapminder data, subset to population, and then take its mean, and then take its log. It is left to right. We get the exact same result, except now, instead of reading inside out, which quickly gets messy as you get more and more functions inside one another, we are reading from left to right. Okay, this is kind of nice. So we're reading our question. What does percent mean in an R sentence? Percent means a variety of different things. So this pipe operator that is percent greater than percent, this is actually a single function. So the percent itself doesn't mean anything. Rather, the percent sign is often used as a writing convention in R to note the presence of operators. So many operators in R have percent signs on the outside of them, and most pipes have percent signs. It's just a convention. The percent sign itself doesn't mean anything. Does that make sense? Okay, so this is a pipe. Pipes are super useful, and we're going to spend the entire term playing with pipes. And I will try to sell you on the idea of piping things. Piping things gets really handy when you want to run a lot of things sequentially. And I'll probably show you today, if there's time, how out of control it can kind of look. I like to pipe sometimes hundreds of function calls in a row together in pipes instead of like writing files and things. It ends up being something very comfortable to do, and you'll get used to it. Okay. So the way to read this again is to send that Gapminder population data to mean, then send the output of the mean function to log. Okay, left to right. In your head, you can read those the percent greater than percent pipes as the words and then, if that makes sense. Okay, so let's say we want to filter our data down in this Gapminder data. Here's an example of filtering in dplyr. I say, take the Gapminder data and then filter such that country equals Oman. And what do we see here? We see every observation for country is Oman in the data set. What this is saying is we can take our Gapminder data and subset it down to the rows, that is filter is subset to rows, where country is equal to Oman. If you remember from lab, when we did a little bit of subsetting, we use equals for testing equalities, not a single equal sign, but two equal signs, okay? We get the Oman data. So there's many logical operators we can use for subsetting data. So when I say a logical operator, I mean an operator that is some function that sits between like two object arguments. There's many different ones we can use to make logical operations. A logical operation is just some test that produces true or false values. We're going to talk about this a lot this term, so you don't have to dwell on it too much. Here's a bunch of examples. So we tested equality with country equals Oman. There's other ones like we could try not equal to. If we wanted every country in the data set except Oman, we could say country exclamation point equals Oman, and that is country does not equal Oman. We could do greater than or equal, less than and equal. If they are numeric variables we're comparing, like year, we could say we want years above a value, below a value, okay? There's also percent in, which I'm going to give some examples of this term. This is used for checking multiple equalities. For instance, we could say, I want country percent in Oman or Yemen, and I could get both of them without having to type country equals Oman or country equals Yemen. We'll have examples of that. We can combine logical conditions to do multiple operations at the same time. For instance, an and means that both conditions must be true to get a true out. So for instance, if we wanted observations of Oman only in 1992, we could say country equals Oman and year equals 1992. The only row we're going to get is Oman in 1992. We could say only one of these conditions needs to be true using or. OR is the vertical pipe or vertical line key. You'll find it below your backspace key and above your enter on the right side of the keyboard. You may have to hit shift to get it. That's your OR operator. So with OR, if I did country equals Oman or year equals 1992, I would get every 1992 observation for every country, and then I would get all of the years of Oman. So it would make either those statements are true, we keep that. Okay? There's also exclamation point, which will invert a logical condition. This will take whatever operator you had and make all the trues falses and all the falses trues. So this is something where sometimes you can think of a way to select the things you don't want, but you actually want the other things. You can put an exclamation point in front of it and it will reverse that operation. We'll see some examples of this too. Okay. We're going to use these a lot, so don't worry about memorizing them. You'll develop an operational knowledge of them by using them rather than me rambling about it. Okay, here's an example of using multiple conditions. Maybe what we want are the observations from Oman after 1980, but before or up to the year 2000. I can say, take the Gapminder data and then filter such that country is equal to Oman and year is greater than 1980, and year is less than or equal to the year 2000, okay? If we look down at these 4 observations we get, they all have country Oman, they are all after the year of 1980, and they are all less than or equal to the year 2000. Because these are and statements, all of these things must hold, and the data we get has all of these things being true. Does that make sense? Have any questions about that? Yeah, one of the nice things about filter is it kind of makes a fair amount of sense. That will not always be true for things we get to later in the term. Okay. So how do we distinguish between using and versus percent, period, percent? I assume they mean a pipe with that. So the pipe here moves data from one side of it to the other. So this says take the Gapminder data and then send it into the filter function. Okay, these ands here are stringing together logical statements. So this says country equals Oman needs to be a true for this thing to be kept in filter, and this also needs to be true, and this also needs to be true. These ands here are not sending this result to the right side of the operator. With the pipe, it's taking this thing and putting it on its right side, if that makes sense. Is that clear? Good. Okay. And it's okay to have me try and rephrase things. Sometimes I'll explain these things, having done this for many years, in a way that makes perfect sense to me and makes no sense to other people. When that happens, please stop me. Okay. So maybe we want to save a particular subset of data that we're going to be using repeatedly. We can save it and give it a name like any other object in R using the assignment operator. So maybe you're going to be doing a whole bunch of visualization specifically with data from China in here. We might say, take the Gapminder data and then filter such that country is equal to China. We're going to assign that to this object named China. So you'll notice here, nope, don't have it here. You'll notice here the assignment is happening first. The idea here is that, oh, well, I want to create an object called China. So I write it first. Then I know I'm creating an object, so I write an assignment operator. Then I worry about how I'm going to create that object after I've decided to create something. So the cool thing with dplyr and with pipes in general is no matter how many pipes you have on the right side of here, they could go down multiple lines of pipes. It's still going to assign it back up here to China at the top. This is really nice because it means you know when you read your code right off the bat what this thing is you're creating, and then you can follow the code necessary to create it. Okay? Then here I do head China, and you can see the first 4 observations of this. They're all country China, so it looks like my filtering worked. So here's a question. Okay, could you go over percent and percent in again? I'm still confused about what that means. So I haven't really dwelled on percent in over here yet, and I would actually like you to not worry about it because that gets into detail on that next week. We'll spend a bunch of time on it. Just know that there's an operator that allows you to check multiple values, but it's not critical for this week. As far as the pipe operator goes, So %in looks a lot like the pipe, right? The pipe that sends things from the left side to the right side has percents on the outside and then a greater side. There is no necessary connection between the fact that %in has percents on the outside and the pipe has percents. It's just a syntactic way of indicating it's an operator based on the idea you're probably not going to create a lot of objects with percent signs on the outside, so it sets it apart in your code. There's nothing special about it. Does that help at all? And next, do you create dummy variables using similar logic? For creating variables, we're going to use a different function called mutate, which I don't cover in this lecture because next week is an entire lecture on creating variables, summarizing data, and merging data and stuff. But it would be the mutate function. If you're interested in creating variables, particularly like dummy variables and stuff, come to lab and I'm happy to jump ahead in the lecture material, but I don't want to get into it yet. I'm going to be blowing people's brains up enough without introducing data manipulation too much. Okay. So we can save a subset like that and use it. So the actual unit for today is our unit on ggplot. So I'm going to get into it now. So I've shown you some base R plots before. Base R plots might look something like this. So I've taken my China data. I've created a scatter plot of life expectancy on year. I've given it a nice X label, a Y label, a main title. I've made the dots red. I've made the labels a specific size, the title a specific size, and I've made the dots a particular size. I've been very picky with this plot, but this is a base R simple plot, okay? We've seen these before. Great. Now you can discard all knowledge of these for the rest of your life because we are never going to plot anything using base R again if we can help it. Okay. An alternative way of plotting, which many people, in fact, in the R world nowadays, most people prefer, myself included, except in rare circumstances, is the ggplot2 package. ggplot is part of the Tidyverse, so you can load it either by doing library Tidyverse, it will load it, or library ggplot2. The idea underlying this package is something called the layered grammar of graphics. There are multiple journal articles in a variety of great outlets written on the concept and the logic and philosophy of this grammar of graphics. If you're interested in it, you can read it, but it's not necessary to understand ggplot. It's pretty intuitive. Okay. The general idea, though, is that we could break up elements of our plots into pieces and stitch together separate pieces. So instead of doing one function call where we have to give it lots of arguments, we do small function calls with a few arguments and then just add more functions to it to keep adding elements to our plots. That is, we build them up piece by piece. This actually sort of mimics the way we're going to do data analysis with pipes, where we pipe into one function, then add another function to it, then another function, then another function until we end up where we want to be. Okay. So this is the same plot, basically, of Chinese life expectancy in the base R1 done in ggplot. I say here, we're going to create a ggplot. The data is the China data. Then we have this odd thing, AES, which stands for aesthetic, X equals year, Y equals life expectancy. So this says, I want my X-axis to be the year. I want the Y-axis to be life expectancy. You'll notice this right here is an entire function call. The parentheses end it here, that's one function. Then what we do is using a plus sign, plus we add another function to it, which is called a layer, geom_point. What this does is draws the actual scatter plot dots on this plot. So we've basically initialized this plot with some data and an X and Y axis and added dots to it. Okay, we're going to spend a lot of time today with this, so it's okay if this is like a little bit odd. Okay, so I'm going to go over the structure of these to prime you on how a ggplot is constructed, and then we're going to walk through building many different plots to show the logic of it. Okay, so ggplot graphics objects consist of two primary components. They consist of layers. The layers are the actual components of a graph. We add layers to the ggplot object using plus signs. These layers include things like lines, shapes, text. So things like the axes, the lines that connect dots on a line plot, the dots themselves, bars for a bar plot. These are all layers that we would add onto it. The other components are aesthetics. Aesthetics determine how layers appear in that plot. So with aesthetics, we will set them using arguments inside layer functions. We'll do things like say color equals red if we want our layer of dots to be red dots, okay? Aesthetics will include things like the locations of them, like the dots, the location of the dots. On the previous plot, x equals a variable, y equals a variable. Those are aesthetics saying we're going to make dots, but the aesthetics say where those dots are going to be, okay? Aesthetics will set locations, colors, sizes. They also determine how data map to appearances, okay? So that is, how do variables control how a layer looks is a mapping aesthetic, okay? So what is AES again? AES, yes, is aesthetics, okay? There's another question I missed. I see in the IR script you're duplicating code and comments. Is just to make it pop up on the slides, or should we be doing that too? That is absolutely just to make it pop up in the slides. So this is something where some of the code I've written in there might seem odd and there's duplicates. It's because I'm doing fancy stuff in the slides behind the scenes. I'm sorry if it's confusing. Okay. You might notice that some of the ones that are duplicated will have, some will have like echo equals true and the other one will have eval equals false. That's because you're supposed to run the one that is like eval equals true and not the one with eval false. Okay. So there's many types of layers, okay? So layers, the components of the graph, include, for instance, the base ggplot call. What this ggplot call does is it will create sort of that background and the axes for the plot. You use it to specify the input data for the plot. geom_point will draw scatter plots on your plot. geom_line draws layers of lines. ggtitle, xlab, and ylab are layers that add or modify the title, the x label, and y label of your axes. Facet wrap is a layer that will split your plot into multiple plots on some variable, which is really fancy, and we're going to spend some time on it today. Facet grid does the same thing, but over multiple variables. There's also layers that will change the look of the entire plot. Things like theme BW is theme black and white. What it will do is it will replace the background with a black and white background and change some of the other features in the plot. So there's built-in themes to modify how they look. I'll talk about advanced themes a little bit later too. You can go pretty wild with them. So layers in a ggplot are separated by plus signs. Normally when writing code, I give every layer of a plot its own line of code, unless it's something really short like X label or Y label, changing something. In these slides, I occasionally have multiple layers on the same line because of space constraints. Okay. Oh, so here's a question. Once we specify the data we want to use in ggplot, we don't need to reference it again in geom_point. No, this is actually the cool thing about ggplot. If you're only using one data set in the plot, you only mention the data one time, and then every subsequent layer, you can call on variables in it without going back to the variable itself or going back to the data themselves. So you never have to use $signs or subsetting in ggplot. It just calls back to the data. There are more advanced ways to use multiple data sets inside a ggplot, but it still works the same basic way. You can reference it and not have to use subsetting operators. Great question. Okay. Then there's aesthetics. So aesthetics control the appearance of layers. Things like X and Y coordinate values, the color of elements based on a data value. Groups. Groups are useful for saying that certain observations in the data are conceptually grouped together. For instance, if you have a whole bunch of dots you want to link with lines, you would make it so all those dots belong to the same group. We'll show how to do this. Size is another aesthetic. Maybe you want some really big points on a variable, really small points for other values of a variable. There's also alpha, that is setting the transparency using data values. This is something I commonly like to do. I like to, if you have lots of dots on a plot, if you make them partially transparent, you can see all the different dots at the same time. Okay. So layers take arguments to control their appearance, such as point and line colors or transparency. There's two different ways that you can give arguments to a layer to control its appearance. There is setting and there is mapping. So arguments like color, size, line type, shape, fill, and alpha can be used directly on the layers that is set to a fixed value. You do that like geom_point color equals red. This is called setting a value, and it would make every dot drawn by geom_point be red. Okay, it's called setting because it's set, it's fixed. These do not depend on values in the data. Alternatively, if you put these arguments inside AES, the aesthetics function, they will become mapping aesthetics. Mapping aesthetics depend on the data. So if I do g_on_point AES color equals continent, each continent in the data will have a different colored dot, okay? So instead of making all the dots the same color red, they will vary depending on values of the data. However many different continents there will be that many colors of dots, okay? So AES in the overall ggplot, so in the first ggplot call you do, you can set an AES in there. The aesthetics set there will apply to every subsequent layer in the plot, so you don't have to keep redoing aesthetics over and over again. You can override those aesthetics by doing AES inside something like g_on_point if you want to modify like one thing. We're going to see some examples of this in here, so don't worry too much about it. So this use of language and my enunciation on it may seem pedantic, but precise language is really important when you're writing code and searching for help. If you know to search for, I want to change how an aesthetic is mapped in my ggplot, you're going to get much better answers in your Google search than if you were like, how do I make colors what do? Okay? It's a really good idea to learn the proper language for it. It can be annoying, it's a lot of vocabulary, but it's very useful, trust me. Okay, now let's actually see this jargon in action. So I've just given you a ton of information which has no anchor in reality. So let's put them into use. Okay, so the first thing you do when you create a plot in ggplot is you'll create the base plot. So what I'm going to say here is I'm going to create a ggplot. The data is going to be my China data. Aesthetic, the x-axis is year, the y-axis is life expectancy, but I haven't added any other layers to it. So the plot I get here has life expectancy on the y-axis, year on the x-axis, and nothing in the plot. Well, I haven't drawn dots with g_on_point, I haven't drawn lines with g_on_line, so instead I just have an empty plot. I can add to this g_on_point, and all it does is add the dots. The dots, you'll notice I don't have AES in here. It's taken the AES from this original layer and put it into g_on_point for me, so I don't have to manually put the AES in every single one of these. It knows I want the X location of the dots to be year and the Y location to be life expectancy. Does that make sense? Okay, so I've added that on. Next, I want them to be red dots and I want them to be size 3. These are setting aesthetics, so I put them in the g_on_point call. So you can see I take the exact same thing, but I just say color equals red, size equals 3. So now I have set an aesthetic to make the points larger and red. Okay? Next, I want to change the X label from year lowercase to year capital. It's a minute change, but I'm picky about these sorts of things, so I'm going to do it. Then I change the Y label from life exp to life expectancy. And you'll notice I just keep adding function calls with pluses. Each one gets its own line. I just keep tagging them on. The important thing is each one of these lines ends with a plus, so R knows to continue on to the next line. Okay? Then I change the title. Well, rather I give it one. GG title, life expectancy in China. It's a layer, just modifies the plot a little bit. Okay, and then I change the theme. So I say theme black and white. You'll notice it changes how the whole plot looks. It kind of reverses the colors in the background. Theme black and white changes the whole theme. Okay? Then I want the text a little bit bigger because it's small. So I change as a setting argument inside theme black and white, base size equals 18. This changes the default font size for all text in the entire plot. So when I do that, you see everything, the tick mark labels, the labels over here and here, and the title all increase in size. So it's sort of a uniform way of scaling all the text on an entire plot. So instead of, say, in base R, doing cex.label equals this, cex.main equals this, and all that, you do it on one base size and it does the whole thing. Okay. Do we have any questions about that so far? Okay, here's one. Is there a specific place where we can get options? For example, the color options, the theme options. Yes, there's all sorts of places that you can go. So there are vignettes for ggplot. There are cheat sheets. There is literally a textbook on it. And in my favorite place to get information on using ggplot is a book I'm going to plug at the end that is also free and online. And it's Kieran Healy's SocViz textbook on visualizing data. For the most part, there isn't so many options that it's kind of hard. You don't want to like look at a list of them because there's thousands of things. Rather, what you want to do is kind of either Google what you're looking for or go to something like the R Graphics Cookbook, crack Kieran Healy's book, look in R for data science, some of these core resources, or reach out. Yeah, a lot of different places you can go though. If you want to find like the main options for it, there is a manual. So Tidyverse on the website, they host manuals for all the packages. The ggplot one is there, but it's basically the help files from the functions, which are kind of hard to understand. It's better you should get worked examples. Okay, so next one. What is the default font size when you don't specify the base size? This is interesting. It's not a fixed font size. Instead, it's relative to the size of the graphics device. So if you change the size of the plotting window, all the text size will change. This is sort of an unusual thing. It's hard to pick a specific font size. If you want a specific font size, say in an R Markdown document or something like that, what you want to do is fix it to an appropriate size and then set the number of dots per inch in the graphic and then index that to the font size. It's actually fairly complicated. Making truly publication-ready graphics involves a little bit of finesse. Okay. Next. Is there a way to center the title of a graph? Tried to look up the documentation, but the link in the previous slides goes to a 404. Oh, perfect. Broken links. Can you send me an email on that broken link and I'll fix that? Anyway, the way to center it is with a somewhat complicated looking thing. So what I'm going to do here, I'm just going to go R script. I'm going to say, let's go mtcars, ggplot, AES, x equals, let's go with, is it weight? I think it's WT. Y equals, I think it's MPG, is that correct? Oh, I should probably load the packages I'm going to use. Okay, got those. I'm going to do a quick G on point here. And then what we want to do is we want a title. We've got a title, and then we want to modify the location of this text, okay? So I'm going to say, this is something we'll add to the theme call. I haven't introduced the theme layer yet. I will in detail later in this lecture, but this is how you do it. I would say theme, I believe it is title, element text, h just equals, no, it's not, no, it's not title. I remember now. It is, where are you? Plot dot title, or is it plot dot title position? There we go, plot dot title. See, I would not expect any person to memorize these specific theme manipulation options like that. I know these things because I've been doing this for an eternity. So looking these things up can be hard. But for instance, this one isn't too bad. Just know that you can modify every individual element inside these plots using this theme layer. But the main thing to do is if you want to do something and you don't know how to do and you can't find it in 5 or 10 minutes of Google searching, hit the Slack channel or hit the email list, preferably the Slack channel for quick questions, and I'll just blast it out and then other people will learn in the process. Okay, next one. Is there a reason the convention is to end the line with a plus instead of start the line with a plus? Seems like it'd be easier to comment out lines of a ggplot if the plus started the line. You are absolutely correct and have actually stumbled across a really kind of funny and annoying thing. Yes, it would be much easier to comment out the lines if they began with a plus. The funny thing about R is the way that R works in most cases is that R will finish executing a line if it ends in what looks like a finished command. What that plus sign says is it is not a finished command. I need you to continue running to the next line. It's actually just the way R works, where if it doesn't see an operator like that at the end of a line, it will stop running a function. So it's just sort of natural to R. I agree totally. And there are some people who figured out some odd workarounds to enable you to do the pluses on the first line, but it's pretty hacky and weird. It would make more sense though. That's a great question. Nobody has asked that one before. That is awesome. Okay, so can we include life expectancy data from multiple countries in the same plot or a different series of commands? Oh, I'm going to show you how that in the next series of plots here. Yeah, you could have every country there. It's just you have to change the type of plot, because if you have it in a whole bunch of dots, it's going to look kind of ugly. In fact, we're going to see that momentarily. Okay, any other questions? I think we are good. Yeah, okay. So maybe what we want to do, as Peter managed to jump ahead and get us on, is perhaps we want to plot all the countries. So we have a plot we really like for China, if we like big red dots. What if we wanted all of the countries? So if I take the exact same plot, but instead of giving it the China data, I just give it the whole Gapminder data set, I get this terrible looking thing, right? So we look over here, we can't tell any of these countries apart. It might be possible to tell them apart, say, if we, instead of did dots, we connected a bunch of lines over time. Well, if I just change geom point to geom line, we get something no more useful. The issue here is that ggplot doesn't know how to connect all the countries together to make a line. So instead, what it's done is it's taken every single dot on our plot and drawn a single line through all of them. This is dumb, and it's probably not what we want. What we can do is we can add an aesthetic. I added it up here in the original ggplot call, okay? And it is group equals country. Now you'll notice how the lines have changed. The lines are now running through the dots for each individual country, so they properly follow the countries. The problem here, though, is I've made big, dumb red lines, so we can't follow the individual countries. So let's remedy that. I just take size equals 3 off. Okay, now we see country-specific life expectancy lines. Okay, this is a little bit better. But maybe what we want to do is something like, let's highlight regional differences. We can't have a color for every single country because we won't be able to tell them apart. There's 100 other things in here. But maybe we could separate out the continents. So what I'm going to say here is, let's do color equals continent. So you notice I removed color equals red from the geom line, and I added color equals continent in this AES in the original ggplot. Oh, well, this is already getting quite a bit better. Now we can see, for instance, that Africa is the red line down here. Europe is this blue line. The blue line's up here, right? These are all individual countries, but they're in different continents, okay? So this is a little bit easier to see, but it's still kind of hard to tell what's going on. Something that might be better to do would be maybe just make an individual plot for each continent. And you might be thinking to yourself, it's like, normally that'd be a pain. I'd now have to go and create 5 different plots. In ggplot, it is not such a troublesome thing. We can add a single layer called facet wrap. Facet wrap tilde continent will make 5 plots, 1 plot for each continent. This is how easy it is to break out separate subgroup plots in ggplot. A single tilde continent, now I have 5 plots. I'm not sitting here drawing out 5 different plots separately. Pretty cool. This is the kind of thing where you start to see the power of ggplot, okay? Okay, we've now broken it out. So a thing here, though, is that it's kind of hard to read the text in here because I've left this big text. I'm going to drop the base size here so the text is smaller and proportionate to it. Okay, so I just removed that base size 18. You notice most of the changes I had to make were undoing things I said in the previous plots. That's pretty common. You'll make some plot that looks really great with some settings, but you can use it as a base and change a few things and you get another one. Most of the plots I have, like in a journal article, are all kind of based on the same text, but I've just modified a little bit so each one does the appropriate thing. You shouldn't really ever have to start from scratch very often. You can kind of grab things from previous plots that look nice. Anyway, so something I could do is, this legend over here is being dumb and sitting over on the right. It's kind of hard to tell on these slides, but this means there's a big open white space over here. It's wasted space. I just so happen to conveniently have a big open space here I could put my legend in. So I say, in the theme call, I would like the legend position to be, these are proportional. x-axis, y-axis. I want it 80% of the way along the x-axis, 25% of the way up the y-axis, which puts it approximately in the center of that pane. Okay, so now we've taken our legend, moved it in, so our whole plot gets to be a little bit wider. We're wasting less white space. Okay, the thing is, though, is that, okay, we have the legend there, but notice we have Africa, Americas, Asia, and so on at the top of these. So do we even need a legend? The answer is probably no. I can say legend position equals none, and it just deletes that legend. Okay, this is something important because if you do something like assign color to country, your legend is going to have over 100 little entries in it, and you actually won't end up with any plotting area left. Legend position equals none will get rid of it so it's not clogging up your whole plot. Okay? Yeah, so we're looking pretty good. Any questions about that so far?
How do we make sure that the text isn't overlapping? Like we've
You're
got
talking, I can't quite hear you.
Can you hear me now? Can you hear me now?
Not sure if talking.
Can you hear me now?
Type text in chat. It appears I'm not getting any audio out of it. He's actually... Here, I've unmuted. I mean, I had him unmuted, but try again.
Can you hear me now?
Yeah, no, I've got you unmuted and I can't hear anything. Oh, you can hear him, but I can't hear him. Oh, well, that's novel. Nope, I definitely have my audio on here. Oh, you know what I bet it is? It's not that my computer is muted. It's that it thinks my microphone is speakers again. 1 second. Okay. Output device. Yes, correct. Okay, can you talk now?
Yes. Can you hear me?
Or not. Maybe it's Zoom that thinks it's... Let me pop open my sound settings really quick. This is killing me. Zoom does this to me periodically. Okay. Sound settings, audio. It's curious. Okay, seems to be working now. Can you talk?
Yeah. Can you hear me now?
Yeah, I hear you just fine. Yeah, that was on my end, my bad.
Oh, no worries. So on my screen, it's showing up as 1950 is overlapping the different plots. Like it seems like the formatting's a little off. How do we adjust the gaps between those? And then also the year at the where it says year at the bottom.
Mm-hmm.
It seems like stylistically it would be better for that to either be over at the left or it's kind of weird where it's floating out in space. How do we mess with the layout of those specific separate plots?
So if you want to mess with just one of them, you can do it with that sort of element text thing I showed before. So if I've got it set up here with like, see how weight is down there, I could say axis dot text dot x element text h just equals element blank, not element blank. I want element text. Silly Chuck, what are you doing? Oh, no, it's axis text position. Where is it? Wait a minute. I actually forget how you do it. That's a different one. So that's justification of that. Axis text x, element text h just 0. Or is it absolute positioning? No. I forget off the top of my head on how you swap the centering of that. So in that particular plot, this here is its absolute center. So to migrate it over to another side, I'd have to look that up off the top of my head. The answer is yes, it can be modified much the way the title one can, but I forget exactly what the command is for it. Don't have to do it very often. As far as the facet spacing goes, that's another kind of an odd one, but it's also set in theme. There's a theme to the theme calls, and that is if you want to mess with a finicky thing, it's probably going to be in the theme call. And figuring out the specifics of it is usually arcane. I haven't even begun to memorize all the different weird things you can modify in theme. If you email me, and you can't find it yourself, I'll definitely look it up and send it to the class. Is that good?
Yeah, thanks.
Great. Okay, so next one. So how do we make sure our colors are colorblind friendly? This is actually another great question. You guys are getting great questions. I'm really happy with this class this term. So colorblind friendly, there's a couple things. There are palettes that exist in R built in, for instance, with the R Color Brewer package. And I think in ggplot, like Scale Color and Scale Filler Viridis are colorblind friendly palettes. So for instance, I could do something like if I did, give me this. If I did, let's go color equals cylinder, we'll do it, I think. So I've got different colors there. I could do something like, let's make that a factor really quick. Okay, I could huck on scale, color, viridis, categorical, and I believe, oh, discrete to, oh, it's continuous. I want this to be discrete. Okay, so viridis by default gives you colorblind friendly mixes of colors with the correct number of colors for the number of categories or the continuous range of your variables. So for instance, if I did continuous here, made this no longer a factor, which is categorical data, this scale here is a colorblind friendly scale. You'll notice that anywhere where there's would be like a division between red and green, it also fades in some yellow or something else. At least to my understanding, those should be colorblind friendly. There's also some other great options out there. If you search, there's a lot of research on making visualizations as accessible as possible. And there are, of course, multiple types of color blindness, so this won't work for all of them, but this would work for the most common type. Chris Adolph's visualization class, he talks a little bit about making things colorblind friendly. The way I like to do it is use a colorblind friendly color palette and shapes at the same time. If you have two different things indicating the difference between them, it's easy, very easy for people to pick it out. Colors are actually often hard to pick out in many situations between each other, so doing both at the same time kind of helps. Love questions like that. Okay, so I shall continue on. Okay, so you can store plots like any other object in R. If I want to take this plot I created in the last slide and store it as an object in R so that I can just generate whenever I want, I can just put, like we did with pipes, the assignment operator to something way up at the top. So I can say, I want life expectancy by year to have assigned to it this entire plot. If I want to display this plot again, now I just have to enter this object name and the whole plot will pop out. Right? This is kind of convenient. The neat thing is if I display it like this, I can display this object, I get the whole plot out. The cool thing is I can still add new layers to it as if it were that whole ggplot object. So for instance, I could modify the legend or add the legend back in by taking this new object I created and just tack another layer on as if it was that whole stack of ggplot syntax I had before. Okay? This is a way that you can do things like create a particular plot with some data and then have different versions of it without retyping all of your code, right? And later on in this term, we're going to talk about using how to build our own ggplot templates or plot building functions, where you call a function and it will generate a plot dynamically based on different data given to it without having to retype all the code every time. Okay. So a common problem you might encounter is that you want a scatter plot of things, but their units are discrete units. If you plot two discrete variables against each other, all the dots are going to cover each other up. They're all going to be in the same spot. So for instance, the 1982 Africa dots, there are a lot of countries in Africa in 1982. It's just all their dots are on top of each other, right? This is something called overplotting. To fix overplotting, one approach some people take is called jittering. So you can add to position in geom_point. You could say position equals position jitter. And I could say, I want the dots to be randomly distributed up to 0.5 wide. So these are discrete, Africa, Americas, Asia. So going from Africa to Americas is a 1 unit change. So by saying width 0.5, I've said the dots can go up to halfway in either direction. So they don't go into each other's territory, so to speak. And then height is equal to 2. And I just made it so that they could go up to 2 years up and 2 years down because our data are spaced in 5-year spaces. So it's a little less than halfway to the other ones. So now you can actually see, for instance, that there's a lot of African countries, a pretty large number of Americas, lots of Asian countries, a bunch of European countries, you know, and then there's almost no countries over here, right? So overplotting, you can jitter it. A better way often to approach it is to use a different type of plot than something like a scatter plot, because now the positions don't convey the same meaning they would in a normal scatter plot. But sometimes you'll want to do some kind of jittering. I just put this there so you'll know how to do it. Okay. Next, things you might want to do. It's driving me nuts that the math didn't render. I could re-render the slides and fix this math, but terrible. Anyway, changing the axes. We can modify axes on our plots in a variety of different ways. If you want to change the limits, that is the maximum and minimum values on your axes, they're just layers, xlim and ylim. Give them 2 numbers. The first one will be the minimum, the second one will be the maximum, and it will increase or decrease those spaces. You could change the scales with a function, something like making it so the scales are logarithmic or following square unit or square root increments, using scale x or y log 10, scale x or y square root. These will change the actual axes, like all the ticks, all the numbers, so that they increase in logarithms or in square roots. You could also change where the breaks are. The breaks are where these little tick marks are and where the numbers associated with them are, by saying something like scale x continuous. If you have a continuous variable on your x-axis, you could specify specific big breaks and specific minor breaks. I'd recommend playing with those if you're curious how they work. Here are some examples though. So let's take our China data. I'm gonna say, so it looks like the math is rendered on the website linked to the slides. Okay, so it looks like my computer decided not to render the math. It was probably disconnected from the internet at the time, and I have the math render remotely, not in the browser, so that's probably what's going on. Anyway, so I take a ggplot. My data is my China data. I'm going to have year on the x-axis, GDP per capita on the y-axis, and I'm going to make a line plot of this. The thing is, though, is that over the course of from here, the kind of like the mid-late 50s all the way through the late 2000s, China's GDP per capita obviously skyrocketed. So a normal scale probably is not the best way to look at this. We might instead want to use something like a logarithmic scale. So I say here, I want to have my scale for my y-axis be in log 10, so a log 10 logarithmic scale. I want my breaks to be at 1,000, 2,000, 3,000, 4,000, and 5,000. This is just to illustrate that they get closer because it's logarithmic. And then here's a cool trick that I do. You remember how I said that you could call on a function within a package using 2 colons? I say here that I want the labels, instead of setting them manually, so the labels of 1,000, 2,000, and so on, instead of setting them manually, I'm going to make a function in the scales package, which comes with the Tidyverse. I want them to be dollar scales. So what this does is it takes the numbers 1,000, 2,000, 3,000 and automatically formats them so they have a comma before every like 3 numbers and puts a dollar sign in front of them and a cents position. So if you want pretty scales, you don't have to manually assemble them often. You can often call on a function in another package like this to give you pretty axis labels instead of doing it manually. This is a cool thing. If you want to do something like this in work you're doing, look at the scales package and see all the nifty things it can do. It can do a lot of different things. Then another thing I want to do is I decided I want this plot to be extended to begin at 1940 here, and end at 2010 instead of wherever it was going to end. Then I give it a nice title, GG title, Chinese GDP per capita. So this is a way I can take a relatively basic plot and tweak it a little bit so it looks the way I want it to look. So I've messed with the scales, basically. Okay, so here's one. Can you get rid of the cents? There's probably so this is a function, this scales dollar. I would wager that if I say scales dollar, it probably will take somewhere in here, I imagine, with labeled dollar or dollar format, you can probably tell it not to have any decimals. Number to round to. So you could say accuracy. So for instance, here you could say round to a specific value, or say The largest value I'd want to have a cents place, it defaults to 100,000. If I drop this to 500, it would just, the cents place would disappear. So yeah, absolutely. Great questions. You guys are on the ball. Okay. Next. So maybe your fonts are too small. Kind of showed this already. Maybe I can increase these. You know, I'm old, my site is deteriorating. I could increase base size to 20 so I can read my own plots. So there's a lot of small finicky things. I wonder if I reloaded this, if it would, no. Oh, there we go. Fix the math. Should have just done that ages ago. Okay. Internet connection present. I can render my math now. Anyway, so text and tick adjustments. So there's a lot of different ways you could mess with text size, the labels, tick marks, and things. Most of these things occur in the theme layer. Here's some examples. You could do things like this here, plot title equals element text size relative to h_0. What this will do is relative to will make the title twice as big as it normally would be. h_0 will left align the title. Axis.text.x, element text, angle 45. That'll take those x-axis labels on the bottom and rotate them 45 degrees. I'll show an example of this in a minute. If you have crowded x labels, it's often better to pare them down so there's fewer of them or rotate them a little bit so they're readable. Things like that. There's lots of odd little options you can tweak. You name it, there's probably a way to modify it. Okay. Something I want to note though, so you've seen me use like theme _ black and white and theme. These are two completely different types of layer. This is a thing I don't like about ggplot is they've made setting themes like this sound similar to this. If you want to use something like theme black and white and then modify parts of it, you need to make your theme call occur after theme black and white, theme gray or something, because theme gray, theme black and white will set all of these options in theme to a new value. You could then tweak them afterwards with theme. Okay, just as a heads up. So scales. Scales are layers in your plot that will control how mapped aesthetics appear in your plot. You can modify them with the general syntax. There's a million of these functions of scale, the particular aesthetic, and the particular option for it as a layer. An example of this is something like scale line type manual. This will allow you to manually specify the line type for each line in your plot. You might do like scale, alpha, continuous. Alpha is transparency. So this will allow you to have it to modify the way that a continuous variable becomes transparent or non-transparent across values of it. There's also fancy ones like scale color brewer. What this does is it will change the colors that are assigned to variables that are assigned to that color aesthetic based on brewer palettes. If you want to see brewer palettes, go to colorbrewer2.org and you can see there's a million palettes in this thing. This is a way to get nice palettes, some of them, for instance, colorblind friendly, into your plots. I recommend using this often instead of setting manual colors, unless you are really picky like me. I set all of my colors manually because I'm that kind of a person, but you know, you do you. Okay, there are a lot of these different scales for things. It's impossible to go over all of them. Just know the general format. If you want to change like the color of something, it's going to be scale color. If you want to change the color that fills an object, which is called fill, it's going to be scale fill, so on and so forth. If you have questions about any particular scale that you want to modify, just shoot me a question and I'll let you know what the appropriate one is. Okay, so you can also do things like, oh, this plot came out a little funny today. Modify the legend names or the titles of the legends. So this one was meant to be scaled smaller. I've given you a hideous plot for no reason. So what I've done here is I've taken my life expectancy by year plot, put a legend back on it, and then here what I want to do is I want to rename this legend and assign specific colors to each one of these continents. Okay? So what I say here is, because I want to change my colors manually, I say scale color manual. In every scale, the name argument allows you to change the text seen in the title of the legend, okay? So I say here, which/n continent/n are we/n looking at? /n adds line breaks in text. So we see which continent are we looking at, right? I've broken up into separate lines. And because I forgot to scale this one when I rendered my slides today, it overlaps with my x-axis. Incompetence at work. Anyway, so in Scale Color Manual, you can set color values for each value of this variable that we're plotting on. In this case, we're plotting on continents that have continent names. I can set them to colors manually. I say here, the values I want to assign are, I want Africa to be sea green. I want Americas to be turquoise. I want Asia to be royal blue, Europe to be violet red, and Oceania, which is not pronounced the way it's spelled, and this annoys me every time I read this word, is yellow. Okay, so this is how you might manually set them. I dwell on this a little bit. I asked for at least one manually set color, set of colors or things in a plot in the homework. Play with it. You can do something as simple as this, or go wild with the sort of example I'm going to show in a minute. Okay. So this is the example of an enormous, complex ggplot doing way too many things to make a very finicky plot. I'm going to walk through what this is just to give you an idea of sort of the bizarre realm of possibilities you can have with ggplot here. So I call this my fussy manual legend plot. So there's a ton going on here. So we're using our Gapminder data. We have year on the x-axis, life expectancy on the y, grouping on country. But then we got a lot of weird stuff going on here. You'll notice I have geom line, but I have another geom line call over here. I have two different line plots going on at the same time. I'm faceting things. I have a manual color scale. I have a manual size scale. And I've also done things like move my legend around, customize my x-axis text. I've tweaked everything in here manually, right? This is to give you an overwhelming example of how finicky you can be with this stuff and to see the process of doing it. So what does this plot look like if we run it piece by piece? Okay, so the first thing I've done is I've taken my Gapminder data, I've given x-axis year, y-axis life expectancy. So we get y-axis life expectancy, x-axis year, nothing new here. Next, I do geom line. This produces the same line plot we had before, country-specific lines for life expectancy over time. Then here I add a second line. It's hard to tell. You can just barely see some extra lines are popping up. This is a geom line, statistic equals smooth, method equals low S. For those of you who took like a visualization class from Chris Adolph, a low S smoother is just basically a way to create an average line through a bunch of other lines or observations. This basically is continent level. You see group equals continent. I've made continent level average life expectancy lines that go through all the points. Unfortunately, the color is black, so they don't jump out and they aren't visible. Then I facet wrap on continent. So we have one plot per continent. I've specified I wanted 2 rows of these. In facet wrap, you can specify either the number of columns or the number of rows that you want. Okay. Next, I do something wacky. So I do a couple things at the same time. You'll see here I add to geom line the first one, color equals country, and in the second one, color equals continent. This line is for countries, this line is for continents. I'm naming them text. What this is me doing is saying to ggplot, instead of mapping this to a variable or even a specific color, I want you to go look in Scale Color Manual for a color assigned to country or continent. This is very complicated, so don't worry about being able to do this yourself, but know if you ever want to do it, you can do interesting things. What this does here is for geom line here for countries, it's going to say, how do I assign a color to it? It's going to go down and look in the scale for color, look over here for country, and then assign black to all the countries. For this line here, it's going to say color equals continent, go down and look in your scale for color, look in values, look for continent, and assign blue to it. So the blue lines are continent level lines, the black lines are country level lines. Okay, complicated, but might make sense. It's okay if it doesn't. Then I add scale size manual, and I do the same thing. Size equals country, size equals continent. Scale size manual, I make country equals 0.25 and continent equals 3. Now down here, we have tiny lines for countries and really big lines for continents. Okay. Next, I say alpha equals 0.5 in both lines. So alpha equals 0.5, alpha 0.5. They are now 50% transparent. So you can see where the lines overlap, and you can see the lines underneath the continent level ones. If you have a lot of stuff that partially overlaps, a little bit of transparency can help with that. Then I say theme minimal, base size 14. I change my Y label and my X label. I don't need an X label. We know that those values are years. I change it. Oh, I accidentally made my Y label years. These slides are shoddy this term. I've been very lazy. Okay, ignore how bad that is. Then I add a title, Life Expectancy 1950 to 2007, and notice I've added a subtitle. So we see Life Expectancy 1952 to 2007 by continent and country. I like doing subtitles and things. It makes them look classy. Then I rotate my x-axis text 45 degrees by saying axis.text.x equals element text angle 45. This is sort of one of those things you can sneak in there and rotate them down. So here was a question. Somebody asked, why do only some of the continents have x-axis labels? So there shouldn't be any x-axis labels on this one. What we do have, however, are you asking about 40, 60, 80, or is this something on a previous one? Because all the continents should have Africa, Americas, Asia, Europe, Oceania. Okay, then I go again. Next thing I do is I change the legend position and bring it in. And in this case, the legend is actually useful because it lets me say the big blue ones are continent and the small black ones are country level ones. So we can convey like a lot of information at once here. Here's another question. I can see years on, are the different geom lines layered based on which comes first? Yes, that's actually a great thing in ggplot. The order in which your layers occur, that is the order they get displayed on the plot. Whatever comes last will be on top. So if you want something under something, you put its layer first, and then the things that come after it will go on top of it. Okay, the next one. Oh yeah, the years aren't on America's. Oh, you mean that. The years aren't on America's or Africa's x-axis. This is the default behavior of faceted things. So it makes the assumption that you can read this 80, follow the line all the way across, and this like 1980 and the line all the way up. So it gets rid of the intervening numbers here under the assumption that because they're all lined up, you don't need them. You can, in facet wraps options, change that and make them display on all of them, but it's usually not necessary. Okay. Yeah, so absolutely right there, Drew. Okay. So the final plot looks something like this, and this plot actually might convey some useful information. If you want to know about some of the odd observations in here, you could see where they're at, and you might want to figure out what they are. So for people's history here, what happened in the early 1990s in Africa and the mid-1970s in Asia that would cause life expectancies to suddenly drop for a single country? Anybody know? Hell yeah, Peter, you were on the ball. This is genocides, okay? Yes, Rwanda and Cambodia. So this is the Rwandan genocide. This is the Cambodian Khmer Rouge genocide, right? So as a demographer, these sorts of things always jump out to me when I do these plots. Big declines like that, basically nothing causes that except genocide. So that's your uplifting history for today. Okay, so some more on customizing legends. You can do lots of stuff with legends and things, but they're finicky to work with. Like you can mess with their orientation, remove them, move them around, change what's showed in them, not mess with how they look. I recommend looking at like the cookbook for our website or the R graphics cookbook for these things because they're complicated and they tend to be specific to individual plots. Okay, so if you want to save a plot that is like onto your disk to put into a document or something like that, or to email somebody or something, you can do that with the ggSave function. As a first thing to note, when you knit an R Markdown file, most of the time, the plots you make are automatically saved in a figure folder in .png format. So you could browse into it and you'll find if you've made plots, there's usually a figure folder there. If you have an option that makes them integrated into the HTML document and embedded, that may not be the case. If you want to save a copy, say a different file or something you need to send, like often journals require every image in it to be sent as a separate file, you'll want to save them to disk. To do this, you'd use the ggSave function. So you can say, ggSave, I saved a PDF file, the plot you want to save, which you will have created as an object, and then its output height, and then the units it's in. This would take my life expectancy by year plot, make it a 3-inch tall, 5-inch wide PDF plot, okay? You can choose different things like PNGs, JPEGs, SVGs. So for my slides, I usually use SVGs, which are really nice. PDFs are usually what journals want, but there's other output formats too. Oh, so here's a question I missed here. Could you have specified color equals black directly in gonline instead of including scale color manual? How would that change the plot? The answer is yes, it would actually look probably the same. So that was a way for me to give an example of how you can do fancy things with scale color manual, but it's actually unnecessary and I could have set them instead of mapping them that way. Absolutely right. There's usually a million ways to do the same thing. Here's another question. Can we change the position of title, for instance, put the title below the graph? Yes, there is a title.position argument for theme, and you can give it like bottom and it would move it to the bottom. So a lot of journals and stuff, they want their captions at the bottom. You could do it that way. Yeah, absolutely. Okay. So this is a reproducible, great way to produce graphics to like hand to a journal or something. If you want to give somebody something quick, like you're just sending somebody a quick plot, another thing you can do is display it in your plot window and export the plot or take a screenshot or snip. So I say this is a bad, non-reproducible way, but to be very clear and honest, I do this all of the time for simple plots. Bad me, yes, but it's a quick way to do it. If it's a quick throwaway plot, take a screenshot of it and shoot it. It can be fast. Here's another question. Should we be using hex rather than named colors? You do you. I specify hex colors in all of my things, but most people prefer, so R has weird built-in color names. If you get used to them, that's fine. I usually do hex colors for everything so that, for instance, because this is how picky I am, all of the purples everywhere in my website, in all of my slides and all of my plots are the same hex purple, including like the little outline in my plots and the bold here. This is purple, and I've matched it between these things because I'm that kind of person. I use hex codes for that. If you're not that kind of person, don't feel obligated to do so. Okay, so yeah, you can save them. So one last thing I want to show as a bonus plot. Are they official UW purple? Great question. Yes, it is. It's actually UW's official dark purple hex color. That is me. Yes, that's me. It's the essence of Chuck right there. Okay, so a bonus plot here. So I've shown you sort of fast graphics good in these sorts of slides, but ggplot is also suited to making relatively complex publication-ready plots. Lots of people, myself included, use ggplot without doing any sort of post-processing to do plots that go in their journal articles. This, for instance, is the complete syntax for one plot that's in that linked journal article of mine that popped out in 2018. This is the complete syntax for it. There's a lot going on here. I take some data. I have an X, Y, and group aesthetics. I have faceting. I have error bars. I have points. I have manual scales, manual titles, labels, legend positions, backgrounds. But honestly, that much for generating an entire publication-ready plot isn't that much. What does this plot look like? It's not the prettiest thing, but it conveys a lot of information. So what this is here is a figure showing the probability that an individual that somebody in the community called the police on, the probability of them getting arrested, stratified by the race of the person reporting them to the police, the race of the person who the police were called on, and the neighborhood they were in, and the type of crime the police were called on them to begin with. So what this shows, for instance, is if you are A black individual in a stable white neighborhood who a white person calls the police on you for a nuisance crime, your probability of being arrested by the Seattle Police Department in this period of time is about 87.5%. Okay? So this conveys a huge amount of information in one plot, and this is just a facet grid, a geom point, and a geom error bar, and a little bit of massaging to make it look nice. This plot and a few ones like it are in that article. So ggplot, this is something very useful for your general work. You can make fast plots with it, but you can make publication-ready plots too. Okay. And if you want to see the exact process for generating this entire thing, I also have all of the code necessary, including making the data in my advanced counterfactual slides, which we'll talk about later on in like week 10. Okay. So I have to make a plug for this. I mentioned it before. This is a book I'd like to recommend. I have it here on camera as well. Kieran Healy's Data Visualization, A Practical Introduction. This is a book targeted at social scientists without technical backgrounds. It's a great introduction to general good visualization principles. It uses R, it uses ggplot2, it uses the Tidyverse. It also has a basic good introduction to R in it. The textbook itself is affordable in print and is really nice. It's a great book. It's beautiful color and everything. But Kieran Healy, being who he is, has also made the book free and online via that link. So you can click on it and get all the content in it. I bought a hard copy because I think it's a great book. Well, actually, I don't think this is my hard copy. This is probably my girlfriend's hard copy. She bought it because it's a really great book. Anyway, yeah, I recommend this a lot for data visualization. Kieran Healy is a really good data viz person and would teach you stuff better than I could. So rather than getting into deep stuff with me, I recommend this book if you really want to get serious. Okay, so some tinkering suggestions. These tinkering suggestions are things I suggest for you to do in the homework for the week, things you might mess with as examples. Just experiment with the Gapminder data. Things like you can subset to different rows with filter, plot different X and Y variables, try faceting on things. You might try plots I didn't even show in this lecture. For instance, there is a histogram geometry for histograms, density plots, box plots. There's a ton of these different geometries. Cookbook for R shows you a good reference for all these different things. You might do things with like geom smooth, which will add regression lines or low S lines to scatter plots and stuff. You might also do things like mess with special themes. So Jeff Arnold, who used to be at UW, made a package that has themes that make your plots look like they're in The Economist magazine. They make it look like, for some reason, you might want this, make them look like they were generated by Stata, make them look like they were generated by Excel, things like that. There's also packages out there. For instance, if you go, the UK's BBC has an entire package to make plots in the style of the BBC's webpage, because it turns out they do all their plots in ggplot. So you can go and make them look exactly like their publication-ready plots. This is actually sort of, it's not really a secret, but a lot of news organizations, magazines, stuff, they do their analytics in R and they're plotting in ggplot. And often they share their code for those things, so you can go and steal it and use it, because it's typically open source. So I recommend playing with some of these things. Do whatever you want. Okay, so the homework for this week, just pick some relationship or multiple relationships in the Gapminder data and write up a little RMD file that investigates that graphically. You might work with a subset, for instance, maybe just look at African countries or something like that. But you could look at multiple subsets, do whatever you want. Again, upload the RMD and HTML file on Canvas, do 4 to 8 plots. I want all titles, axes, and legends to be labeled clearly. Don't use raw variable names. Clean them up to look nice. Use at least one facet wrap or facet grid. I think that's a really important and useful, like, skill to have in your toolbox. Faceting things is super handy, so I'll make you do it. Do at least one manually specified legend, just one, so like scale, color, manual, or whatever with its legend shown. Use whatever geometries you want. You could stick to only the ones I showed in my slides. That's perfectly fine. But you might play with histograms, bar charts, try and add vertical, horizontal lines, whatever. There's a cheat sheet here from RStudio that gives you an idea of some of the other things in ggplot you can play with. Like the previous homework, make it pleasant for a peer to look at, some minor organization, write up a little bit of observations and words. Don't go crazy. A sentence or two after a plot is sufficient. Just say what we're looking at. Use chunk options like echo equals false. Make it so they don't see any code at all in the document, ideally, just the plots and the text. And that's about it. So people have questions? Great question, Alex. So can you recommend a comparable book for engineers, or is it suitable for those fields too? The answer is it is suitable for those fields too. Well, it's targeted kind of at the social sciences. It is a general book in data visualization. So it uses a lot of demographic and social data and stuff, but there's nothing unique to those types of data. You tend to have the same kind of data types, continuous data, discrete data and stuff. I'd say it applies to it generally. There are some other books out there that are good. I'm trying to remember off the top of my head. There's a great visualization book that came out recently. I forget what it is. If you email me, I'll get it back to you. And I think it's a slightly more general one. But in my opinion, this data viz book is probably the best one for ggplot in general. Usually it's about the tools, not about what is the data or the content you're producing. Okay. A bit unrelated, what was covered today. Does R Markdown have a spell checker for things we write outside the chunks? Yes, as a matter of fact, in the newer and development versions of RStudio. So I believe in the current version of RStudio, if I start writing in a, let me drop over to here. Okay. So if I start writing in, I'll just open a chunk in here. Okay, my version doesn't have it. So I usually use the development version of RStudio, but I think I'm using 5033. Okay, yeah, so the version of RStudio that I basically asked you all to install, the basic version of it, does not have a spell checker. If you want to be a fancy person, and this is what I normally do, RStudio daily builds, there are test versions of RStudio, and you'll notice the version number is quite a bit higher, 1.4.166. This one has the fancy features. It has built-in spell checking and things like that by default. So if you want that, you might experiment with it. You won't break anything by doing it. Honestly, the daily builds, I've never really had any substantial problems with them, so I usually use them. I forget why I'm not using the daily build right now. I think it's just because I did a fresh install. You might do that and try it out and see, but I know it has built-in spell checking. They just haven't released it yet. Okay, another question. Unrelated question. Oh, I knew this was coming. I've noticed in your RStudio, when you type that operator, a nice arrow appears instead of that. Is there a way to enable this on my machine? Yes, so I am the sort of person that likes ligatures. These are referred to as ligatures, and sometimes I remember to turn them off before I teach a lecture so I don't show people the dark side. But basically what ligatures do is for all sorts of different things. Like for instance, they probably ligature for greater than and equals. Notice how my greater than equals now became what looks like a single character here. Ligatures do cool stuff like that. So the way to get ligatures first is you need a font that supports ligatures. The built-in RStudio fonts do not. You can add a font to your computer. For instance, Fira Code here supports ligatures. You can do Fira Code and then in code turn on in display, I think it is. Where is it? Editing. There's somewhere you have to manually turn on ligatures. Maybe they just go on by default. Yeah, I don't actually see where it is. I think just using Fira Code will automatically make ligatures turn on, probably. Yeah, if you want ligatures, download a font for it like Fira Code, and you should be able to turn them on. So good question, me being sneaky. Any other questions? It's one single plot or multiple plots after facet wrap. It is still one plot. It has multiple panels in it, but it is a single plot. Oh yeah, just put the number in the peer review. So like at the end, do like 3/3 or just the number 3, and that's sufficient. because you're not actually really assigning them grades. You're giving a recommended grade, and I will look at it. Just put it at the end. Yeah, I can do that. So this was one privately, so you can't see it. Somebody asked, will you be uploading the homework 1 examples 1 and 2 on the course website? Yeah, I'll try and I'll remind myself to put those up here after that so you can get an idea what they look like. It's really just, I mean, what people want to do whatever you want, but a couple people made nice ones and I'll just put them up. Okay, I can do that. Anything else? Are you saying to put grades for peer review in the comment box on Canvas? Yeah. Just put them at the end of the text. And it should be clear. I mean, you know, you're not going to be giving somebody a 1 out of 3 without them knowing why, because you've written feedback for it. You can literally say, like, the assignment asked you to make plots, and there are no plots in your ggplot homework, so you get a 1 or 0 out of 3. That kind of thing, right? Okay, anything else? Okay. Thanks for joining me today. I hope you all have a rest of your good quarantine week, and I'll see everyone who wants to come for lab on Monday. Bye-bye.